Oh. All right. Thank you. Okay, it's already. So yeah, let me just go ahead and show you guys. So I was sharing the wrong remix screen before. Sorry. Where is this one? Ah, is my remix hiding now? I don't even know which one I'm opening again. Ah, I don't know. Please give me. Just bear with me. I'm trying to see the screen on. Okay. Okay, let me just stop sharing and share again. I can't find the. You guys can see my screen now, right?
Yes, I
Right?
can.
All right. So yeah, let's quickly. So let's just say test overflow over and underflow. So let's say uint 8 a uint 8 a. Okay, no. Let me just do this instead. Let me just create a function that does addition. Sorry, let me do multiplication, because that way we can have really big numbers. Multiplication. So let's give it a is uint 8 a uint 8 b, and let's give it external. Let's give this return uint 8. So let's do a return a times b. So now we have our basic code. So now let me deploy this. Now, what I'm trying to achieve is I want to try to, the highest value that this uint 8 can carry is 255, right? But I want to perform an operation that will give me a value that will be more than 255. So you see what I'm talking about. So let's go back there. So what is the error? One in blah 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 blah. Okay, pure. Yeah, that solves that. So let me deploy this. Yeah, deploy. Yeah. So now let's pass in 128 and 2. 128 and let's pass in 2. Let's see what we get. So see the value, the answer is 0. The answer is 0, not because of the 128 times 2 is 0, which we all know that is not 0, but because of it can't return to 256 because it cannot allow that. You understand? That is an overflow. Now it has reached the end and it has gone back to the beginning and started counting. So let me try a value like 3, and you see, let me try a value like 3. Let me see, let me try a value like 3. So somebody should help me. 128 times 3 is what?
384.
All right, so 384. So if you do 384 and you are 384 and you start counting from 0 again, you would, like, instead of it to reach 255 and 256 up to 384, you do 255 0 and start counting up to 128. You understand? So let me try the last value. Let's just say we know 50 times 6 is 300. So let's do 50 times 6. Right, 44. 50 times 6 is not 44. 50 times 6 is 300, right? But when you reach 255, you go back and start counting because you can't do anything above that number, right? Now let's try something with, let's try to achieve an underflow. So how will I do this now? Okay, let me try to do okay, it won't work because okay, zero is always the least. Zero is always the least for, but okay, let me actually try underflow with integers and not just unsigned integers. So let's say 0, 1, 2, 5, 5. Okay, let me actually change this to an integer. Let me redeploy this. So let's see the min and max first of all. Let's return the min and max. So it can guide us. So basically we are doing this so we can be guided by these values. So we know the values to play with. So let's deploy again. Now we have the max is 127, then the mean is minus 128. So now let's try something. Let's try to get to do it. Like, tell me something. Give me two numbers that would give me something like minus 130. So minus 2 times 65, right? So let's try that. Minus 2 times 65. Minus 2 times 65. So this is meant to give us minus 30, right? So let's try it. We are having 126. So this is an underflow. The least number that can be accommodated in this range is minus 128, and the highest is minus 127. So when it reaches that minus 128, like, so, like, yeah, when we want to compute minus 130 and it reaches minus 128, you find out that this number doesn't have the capacity, rather this data type doesn't have the capacity to accommodate minus 130. So it goes back to the beginning. So instead of from 128 counting to 130, so it does 128, 127, and 126. So it does minus 128, which is the last number in that range, the minimum value. It now goes back to it goes back to 127, and then it reaches 126. That's why you are seeing that minus 25 times 65, minus 2 times 65 is 126 instead of minus 130. This was the cause of one of the biggest hacks and one of the first hacks in the blockchain, which is the DAO hack. And that's why this is a very important concept. So it will help you understand a lot of things happening. In other languages, you might see these kind of things. Even in Cairo. Okay, go ahead, Elizabeth.
I'm still lost with that calculation because if it is minus 130, how did he now return it to 126? Let's even assume it's from 1 to minus 128. Is it that the difference between the 130 and minus 130 and the minus 126, it now removes it from the positive part? I'm not getting how that value came to be.
Okay. So let me go back. So I said when we tried the first one, which is overflow, right? We reached 120, we reached 255 and started counting from the back because it couldn't accommodate 256, right? So now I'm trying to achieve an underflow, which is in the like the minimum part. So overflow is when you are doing above the maximum value. Underflow is when you are doing below the minimum value, right? So here the minimum value is minus 128, right? And also the maximum value is 127. Now, minus 1, like minus 2 times 65 is minus 130. So the difference between 128 and minus 130 is 2. But that 2, we cannot achieve it in that range, right? So we need to count from, just like a clock. We have reached 12 and we cannot go to 13. So we have to go back to 0. You understand? So now, let's say here now, minus 128 is 12. So he now wants to add 2 numbers to that range, to that particular operation. He wants to add 2 numbers. Instead of it to do minus 129 and minus 130, it will go back to and start with 128. So it will be minus 128, minus 128, 127, and 126, instead of minus 128, minus 129, and minus 130, because you can't represent minus 130 in this particular range. Does this make sense?
Yes, I get you now. I get you.
All right, all right. So this is the whole idea of underflow and overflow, right? And you actually don't need to bother about this now again, because of Solidity is already doing this for you. But having this at the back of your mind will help you make sense of some other concept that you find later. You understand? You even find some languages that will give you values that are even weirder than these ones. Like I'm learning this language called Cairo, and you'll be seeing you actually see a very, very big number just because of you did an overflow, a very, very big number that you'll not even be able to understand why exactly it's giving that particular number. And it's still the same concept. You are passing the range that's meant to. So anything it gives you, you now start, okay, why is this giving us this? But basically, it's the idea of underflow and underflow, because you have passed the range. So it now depends on the language to implement what they're. So they might say that, okay, now in Solidity you have different kind of types. You have int 8, int 16, int 24, int 36. You understand? Do they have int 20? No, there's no int 36, sorry, int 32. So, but in other languages that they might just have the biggest integer. So let's say in 256 is the only data type. So anything you are doing is wrapping around in 256. Though, mind you, the largest number that in 256 can carry is a very, very big number. So yeah, you might likely not pass that range. But if you pass that range, you also see weird values like that. Dolapo, go ahead.
Why didn't it like bring out minus in the output?
Yeah, so basically, when it's doing the whole wrapping thing, it's going back to the beginning, and the beginning is full of positive numbers. So you're talking about 127, 126, 125 up to 0 before even go back to negative. You understand? So it's just like it's going round. So when it goes round, you're going back to positive numbers. So from 128, sorry, from minus 128, if you're going back to the beginning, you're going back to 127, which is a positive number. You understand? So it's not really about the signs now. It's about in this range, what is the next value that I'm meant to fall back on? Does that make sense?
Yes.
It doesn't, right? Yeah, like ask, can you rephrase the question? Let me see if I can do it better, answer it better.
Like, why is it not bringing out the negative sign?
Okay, so like I said, just imagine that we had like the way our walk clock worked. So imagine that instead of 12, 12, 1, 2, 3, 4, blah blah blah. Let's say that we had okay, sorry, let's say that from 1 to 6 is positive, and from 7 to 12 is negative. Let's just say it like that. Now we all know how the walk clock works, right? But what we want to achieve is that I want to convert all the numbers on the left hand side to negative numbers. So we have 1, 2, 3, 4, 5, 6. But when we reach that 7 part, we'll now change 7 to minus 7, minus 8, minus 9, minus 10, up to minus 12, right? This is just for illustration purposes. Now, so what I'm trying to say is that when we reach minus 12, instead of us to do minus 13, we'll now go to 1, which is the first number in that range. Do you get? So this is not a matter of the sign. This is a matter of what is the next number in that range. So we have moved from minus 12 back to 1, not because of 1 is a negative number. 1 is not a negative number, but because of 1 is the next number in that particular cycle that we are going through. Does this make sense now?
Yes, thank you.
Yeah. So Elizabeth, go ahead.
Now, my question is, in what situations do we really need this underflow and overflow?
All right.
What are we trying to do before we could make use of this particular function of underflow and overflow?
Okay. Yeah, that's a very good question. So, like I said, one of the biggest hacks that happened in the blockchain, the DAO hack, happened because of something like this. Now, let's just explain this simple scenario. Imagine that you had okay, let me try to make this make sense. So imagine that the integer type, like actually imagine that the whole amount of money in our contract was 500 ETH, right? And now I own 500. Sorry, I own 250, you own 250. Or let's just say we all own 100 each. So we are 5, we all own 100 each, right? So that's fine. Then someone now tries to withdraw, right? Someone now tries to withdraw. Now the person doesn't have, so the person does, like, person has only 100, but the person now does an operation that is meant to return say 0, right? But now because of underflow and overflowing, it now returns another value entirely. So imagine that we just did minus 2 times 65. Instead of us to get minus 130, we got 126. So now imagine that after this operation, the person is meant to withdraw the amount that it's given. Meanwhile, you are going on the negative side, but meanwhile, because of overflow, you now actually have money that just appeared from nowhere. So this is a very big flaw, because if you perform an operation and now instead of you to be getting a negative value, you're getting a positive value, it means that you're no more owing money, you actually own more money, and now you're eating from other people's money. So now imagine, because of the money stored in the contract itself, if the contract after this operation, the contract say I own 126, I can withdraw 126 even if I know I don't have it. But because of the overflow, something has happened, and there's no way to check this thing. It now updates my balance as 126 instead of minus 130. So now you're not seeing that somebody just generated one, and this will be taken out of other people's money because the money is in the contract, not on the other mapping, on the mapping that stores the balance stuff. So this is just like a simple version of where this might come in. But yeah, this is a flaw, but we don't have to worry about it anymore, because from 0.8 upward, they already did this, and you can, like, it will throw an error without you doing any extra check. But yeah, it's just something to keep in mind. Does this explanation make sense?
Yes, it does. But I was looking at it that, is there no way they could actually set a limit on the blockchain at which you cannot withdraw or carry out transaction beyond the amounts that you have in that contract?
Okay. So these kind of things, you're actually dealing with money. So you're meant to be doing credit and debit, right? So where this thing mostly comes into place, when you're doing debit, and when you now do the debit, instead of it to give you the right number, it's giving you a number that was generated when that value was given when an overflow happened. So it's not like there's no limit, but when you're not doing that calculation and it's not giving you the wrong values, then you now see the problem. Like, we actually have mappings that store these values, right? But when you now try to do this plus this minus this, and it's giving you a value that it's not meant to give you, then that's where the problem comes in. Yeah, we actually store these values, right? There's the limit, the whole thing you're talking about, we store these values. But when you now try to perform operations on that value, right, you're not having no numbers that you're not meant to have. In fact, in some systems, like say pools now, you actually do more complex calculations, like this time this divided by this time this divided by this. And if the output of that particular operation gives you the wrong value, you go into issues. Because yes, the values are stored. But if the output after performing an operation give you the wrong value, then your whole contract is at risk because that's what misuse of that actually hack your system. So yeah, that's it basically.
Okay, thank you.
All right. So let's go to what we have for today. Let me check. Let me check. Okay, I want to show you guys how to write testing, how to test smart contracts. So let's just quickly go over that. So that's among what we have for this week. I have a question. Okay, sorry, I didn't see that. The last call you used versus code you use, it opens everything through your terminal, but here it's showing same thing with Remix. How do you do it? So I think it's just all about the environment. When I did it on Hard Hat, right, I was using it as a node module. I know how they store node modules. You can just go into the node modules and go through each file. But here, as I'm writing out the import statement, Remix is going to get it from me. You understand? So there are two different environments. So that's just how I'm like because of his Hard Hat. I went to check node modules. Remix um does generate it for me. So, and this is not the first time I'm doing it. So I just know that Remix stores it somewhere in there for me. I just go there to look for it. So it's just different environments. Yeah. So yeah, let's see what we have for today. So we've spent how long talking about underflow and overflow? Yeah, I think it's worth it, kind of. So yeah, testing smart contract in Solidity, deploying smart contract with Hard Hat, interaction with deployed contract, Merkle tree. Yeah, okay. So let me stop sharing. Let me share my Remix, sorry, my Visual Studio, and let's talk about Web3. So let me stop sharing this one. Start sharing this one. There. I'm not singing for you, but yeah, you're welcome. So, yeah, how are you, my friend? So, let's quickly go through the tests that Hard Hat gave us because one thing about these tools is that they give you good documentation, at least most of them, right? There are some people that have really crappy documentations, but at least Hard Hat gives us documentation. So I don't really need to cram how to use Hard Hat. I just know that I need how to use that. Go and look at the documentation. So I think where we stopped is it's true. I think I didn't finish ERC 1155. Did I? I'm not sure I finished it.
You did.
Okay, okay. What's one thing that I use I waste my time just to clear the camera. So let's just go through. Okay, I think I didn't finish this part. Yeah, see, I didn't finish this part. Let me just bring this in and okay, before I go ahead, can someone just volunteer to give me a very short explanation of the three types of tokens? Or one person will pick one, another person will pick one, the other person will pick one. Let's just do it like quickly. One person, one person, one person, one person. Quickly. Or should I call somebody? I don't like calling. Please, one person just volunteer and talk about ERC, another person talk about ERC721. The next person talk about ERC1155. Please don't stop for my hand. All right, go ahead, Okechin.
Okay, ERC20 is the standard for fungible tokens.
Okay. Can you give us more detail?
Sorry?
Give us more detail.
More details concerning.
Yeah, like basically, yeah, like I know it's like I don't want to just straightforward operating in fund. Just give your own word, right? It doesn't need to
That is
be
the best way I understood it though. That it
yeah,
is the standard. Because usually, like you said the other day, if there was no standard, anybody could just wake up one day and create any token.
yeah,
But because of the standard, it helps to keep the tokens in, it helps to keep programming in check
yeah.
because it has not become widely acceptable. So for any token to be acceptable, it has to also follow this, it has to meet all the standards as stated in the contract.
Nice, 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 nice. Thank you. Dolapo.
Okay, I just wanted to add that you can like create your own token with ERC20. I think that's what I wanted to add.
Okay, okay. All right, Elizabeth, I saw your hand up.
I wanted to add to where she stopped regarding the standard, that it's like a way of how they've created the standard in such a way that the blockchain, to avoid over inflating the production and the both the production and the creation, the minting of new tokens. So that's the essence of the ERC20. And all other blockchains, Binance, BEP, and all of them follow that same standard. Though people manufacture tokens with other standard, but it is advisable that if it's going to be accepted on the Ethereum blockchain, they have to follow the ERC20 standard.
Yeah, thank you, thank you. That makes a lot of sense. So yeah, someone else, NFTs, ERC721, someone else. Yeah, okay, go ahead, Bakari.
Okay, so yeah, say 7 tones is
Sorry,
like the
sorry.
standard.
Before you go ahead, do I pronounce your name properly? Because I
You
don't.
said Bakari now. Yes, you're right.
Okay, okay, yeah.
Yeah,
So
so yeah, so 7 tone is like the standard um that describes how to like build NFTs.
okay.
Yeah.
So okay, what do you think right now in your own word and based on what you see in your environment, what would be like the best thing to use to explain an NFT? Like what do you see around that is okay, this thing can be an NFT because of its factors?
Okay, so maybe if I do a painting, maybe if I do an art. Okay,
Yes.
but my understanding of NFT is non-fungible tokens, right?
Yeah.
Something that you cannot replace.
Okay.
It's a token. That means you can exchange with it, but it is non-fungible.
Okay. Okay.
So yeah, if that makes sense.
Yeah. That actually makes sense. Thank you. That actually makes sense.
Yeah.
Rita, go ahead. Rita, you're raising your hand. You're raising your hand.
Can you hear me?
Yeah, I can hear you.
Okay, I said based on the question you asked, I just wanted to add to what she said that you said your fingerprint because it is unique.
Yeah.
So that's just what I wanted to add to what she said.
Yeah. Thank you. Thank you very much. Elizabeth, go ahead.
No, that was what I wanted to say. The fingerprint that is unique, or the color of the eye, and that you said is specifically unique to one person. No two people have the same fingerprint or eye color, exact color.
Okay.
So that's what I wanted to add to it.
Sorry, please.
I said
Can I ask a question?
okay. Sorry. I don't know if I said color, but there's this pattern in our eyes. It's not the color. Sorry, I don't know if I said color, but it's not a color. It's like this things like veins inside of the eyes for people that they do like medicine and things like that. But yeah, they're like these patterns in our eyes that are unique, but not the color. I think the colors are like they are people have the same colors of the eye. Yeah. But yeah, thank you very much. Bakari, go ahead.
Okay, so if my fingerprint should pass as an NFT, but my fingerprint doesn't have like a monetary value.
Okay. So first of all, why would you sell a monkey for 20 million? Or why would you buy a monkey for 20 million? To be honest, it doesn't really make any sense.
Is
So
it meant?
NFT, it's like a picture of a monkey, not a monkey. Understand? So a picture of a monkey or one picture that's not even final, sorry, for something million. I know art is worth something, but if you see the way they sell these things, you just know that it's not really about the value that you think it has, it's about the value that the person who owns it says that he or she wants to sell it. So I can draw one nonsense thing like this now and explain one deep thing. I'll tell you that this thing is a new blah, 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 blah. I just know that I'll just explain one nonsense around it. And I'll tell you that it's so deep. You self will say, wow. Meanwhile, to be honest, to me, I just want to make money. I'll not say that is I won't sell it 60 million. One rich crypto guy like this will come and buy it from me. Does it really make it? So basically it's all about what do you perceive it to be like? You understand? I can do anything tomorrow and say that this is what it means to me, and I say this is what I want to sell it. And it's not like I'm begging per se. It's not like I'm begging. You just put it there and say like this is what I want to sell it. If you feel like it's something you want to buy, come and buy it. You understand? So yeah, NFTs because of it's not exchangeable. No one apart from the person that owns it determines the value. You understand? So you're the one that determines the value. Yeah, go ahead.
Okay, so I am. It's a question because I saw. Okay, was it not last week? I saw on TV of how art is now placed on the Web3 as NFTs. But now my issue is that okay, I say I want to sell an art for 60 million and someone buys it. The person who buys it, what exactly would the person use it to do? Is it just a collection? Like I'm just purchasing it, or the person still has a monetary value that the person is going to gain from buying it?
Mm,
Because and most of these characters I see on the Web3, I look at it that people actually design these things. They're not looking nice, and they sell it for huge sums of money. And I'm like, how will I buy something like this? So that's I'm trying to see that okay, now you buy an NFT, what monetary value does it have for the person who bought it? Is it that the person it will be acquiring more assets, or what exactly?
okay, from what I've seen so far, so they are like these guys called collectors, right? So these guys have a lot of money to spend, and the idea is that they appreciate art and they are buying art. But what I've noticed is that they buy an art this year for 1 million and sell it for 60 million next year. These guys, there are a lot of like they are not dumb, right? So in as much as it looks that way, most of them they call themselves collectors. They buy this year and sell like in 2 years' time. You understand? But some of them, because of yes, it's the market. Sometimes it doesn't go well. Like I actually saw something recently that say an ad that Logan Paul bought for how many million is now worth like $30 or $60. I don't know, but it has dropped down drastically. But most times there are huge strategies around this thing. For instance, now someone that bought a Bored Ape art in like say 2 years ago for 1 million might sell the same Bored Ape this year for 3 million, 5 million. Board apes are still very, very expensive, right? So you might some of them lose doing that, but most times the business part is there. Nobody's foolish in this space. Everybody wants to make money. So yeah, in as much as it might seem like it's nothing, if you actually watch them closely, you see that they sell those things later at higher prices. You understand? Yeah, okay, so go ahead.
Okay, to add to what you just said, I'll say it's all based down to utility, right? Like when the NFT of Jack Dorsey's first tweet on Twitter first came up, within a few hours or a few days, the price just blew up, skyrocketed to millions of dollars. But it did not have any real utility, and so well, by the time he started talking about selling Twitter, the price of that NFT is fell drastically. It lost all of its value. So, in response to her question, some people just see the value of NFTs. They like the Board Ape Yacht and the Board Ape Club. People holders of the Board Ape Club. The one of the utilities of the Board Ape NFTs that holders enjoy special benefits. They can attend Board Ape events free of charge without needing to pay for gate fee or something like that. So for an NFT that has that kind of high utility, anybody will want to buy it. Even if somebody puts up Board Ape NFT for $100 million at this point, somebody will buy it because it has real world utility. So that's just what I wanted to contribute to her question.
Yeah, yeah. Thank you very much.
Oh, okay, thank you.
Yeah,
Well,
yeah. It actually makes sense. But to me, right now, a lot of NFTs don't have utility. But yeah, Board Ape is just like this big boys club. If you're a big boy and have money, come and join us. So yeah, yeah, that really makes sense. Then someone else, yeah, it's 1155. Quickly. We are running out of time already. Please, somebody just help me. I know this one is not as straightforward as ERC20 and ERC71, but just help me. Small, just like few words. Let's go ahead. Okay.
okay, for me, the only thing I actually understood from what you explained the last time is that you said this one is kind of like a combination of both of them, the first two. Yeah, see, 20 and 71. That's the only thing I picked up.
Yeah. Yeah, that kind of sums it up. Okay, Bakara, please go ahead.
Okay, so yeah, it's just like a token that allows you to really perform a transaction using both non-fungible tokens and fungible tokens
Yeah,
together. Yeah.
yeah. So yeah, let me just shed more light on ERS1155. So there's this idea that if you want to create like creating NFTs cost gas, right? And when you know anything that costs money to perform, we need to look for ways that will minimize cost, right? So ERC 1155 basically gives us a couple of options so that we can be able to reduce costs. So basically, we have an NFT project, or rather, we just have a project, and want to launch an NFT. I want to also launch an ERC20. Then we'll now go and launch our NFT project separate, launch our ERC separate. But meanwhile, you can just use one contract and launch both our NFT, our ERC20. You understand? So basically, this kind of contract allows us to create these two tokens and also perform operations like bulk sending. So imagine you want to send token to 100 people at once. You can pass an array of their addresses and send it at once, and only ERC1155 allows that. Or you want to check the balance of 100 people at the same time, you can check that. ERC1155 allows that. Understand? So you have the same thing, safe bulk transfer, bulk balance checking, bulk okay. Let me just go and see. Um okay, batch transfer. Yeah, batch transfer, balance of batch, you understand? Those are like the main two. You understand? So yeah, that's the idea basically. Yeah. Okay, there's one particular post that kind of explains it. I think I'll just share it. I won't go through it, but I'll just share it by Open Zeppelin that kind of explains it. So okay, go ahead, Bakari.
Yes, to not related to anything you're saying, but I noticed that we didn't cover Meco Tree,
Yeah,
and then
yeah.
it's
Intend on covering it. It has been coming. But I think today is already fast spent because it's a dense topic. Even I actually tried to understand it better before having this class with you because it's something that can really um yeah. So yeah, we'll not talk about it today or tomorrow, but we'll definitely talk about it. Sure. So go through this. Okay, go ahead, Bakari.
sorry, that was a mistake.
Okay. So here is this material. for creating for just read about it. Just click on it and read about it. Either this class, why just read about it later. Yes, we'll talk about EtherJS and Web3 JS. Yeah, area 6 for creating NFTs. Yeah, thank you. I did too. So yeah, let's go to so how many of us know how to write JavaScript here? If you know how to write JavaScript, just raise your hand up. Okay. Okay, not a lot of people. 5 people out of.
Yeah, I'm still learning. No.
Okay, okay. All right, all right. All right. I'm quite beginner. Okay, okay. So this is not a JavaScript class, but I'll try to explain a bit because all these things are kind of, but yeah, I'll try to explain it while I'm talking about it. So yeah, I want to show you how we write tests in Hard Hat. I won't run it because of time. I won't write tests for my contract, but I'll show you what the test looks like. And now I want to explain something very well. You know, there's this idea of some people ask, it's programming, everybody wants to know what is best, and everybody have their own opinion. They ask you, should I write tests? So when I started coding, for a very, very long time, I did not bother about tests. I just knew that it was important, but somehow I was not doing it right. But I used to depend on manual testing, just write my code, go and test. For instance, now you create a website and you go to your browser and refresh in the browser, you understand, to make sure that it works right. But if there are some things that you'll be doing, and if you don't test automatically, like you're saying here, you will have issues, right? So I want to see if I can get the contract that came with this. So I'll explain it. Oh, I think I deleted it to what wait, let me how will I do it now? I want to get the contract that came with this. Should I just wait? Let me see something. Um, what do I do? Okay. Let's try to write a very simple contract and write text for it. So let's write a very simple contract. Um, test contract. Because if I start explaining this test now without the smart contract itself, it's just confuse everybody. So let's just say we want to just do basic stuff. No, when we're not doing too much. Let's just do sharp. So contract test. If you don't like the way I use your name things, you can just suggest names for me. Names are finished in my head. I don't have names to give these things again. So yeah, so let's say string public name and function updates name. You can just say yeah, update name external name equals to name. So this function updates the name. But let's just say that initially in the constructor, when you create the contract, it automatically sets the name as my name. So this is the name, update name, blah blah blah. So this is a very, very simple contract. Let's compile this hard compile. I'll say it again. Please always go and do your own research. Always go and do your own research. Okay, MPX. Let me do MPX. Oops. Let me add up the stress this evening. So always go and do your own research, please. Just take your time. All these things is like at the end there. Why is it showing me? Okay, wait. Sorry. MPX. Add up compile. I've done this thing before now. Why is this thing doing me like this? Can you imagine?
I think that's one of the issue of adults. You have to keep updating whenever you want to use it. And this
But
is drains data. Is it not possible? That's why it's looking like his remix not better. For adult, the same thing when I was trying to use when you first of all start the introduction, it had to update to the latest version. It told me there is a new version now. It now updated, downloaded that one again before I could do
I think
anything on it.
what's happening here is not even an issue of version. It's just like telling you that you don't have it at all. Because if you see this thing here, 1.2, it's the same thing that it's giving me here. It's not a different version. I think there's an issue. Because I don't know. I think there's an issue. Okay. I understand. I didn't go into the folder. See my life. Coding is very stressful. Coding is very, very stressful. So let me try it again. You see? It worked. See? My God. Things like this. Now I to code live. So yeah. So let's try to write tests for this code. Test. So now you like here's how I want to actually see tests in programming. When you're writing tests in programming, you're trying to simulate all possible scenarios that your program could have. So now let's look at this code now. What are the scenarios that might come up? Go ahead, go ahead.
Please zoom in. Your screen looks very, very small.
Huh?
Your screen looks very small. Can you like zoom in or expand it or something?
I don't know. I think it's from your end. It's looking normal here.
Okay.
Can is any other person having the same issue? Because it's like I zoomed it out like today.
It's possible, but me, I'm using mobile, so I can increase this. I can zoom it in
On
myself.
PC, it's very small.
But if you are
Yes.
using system, it will be very small.
Yeah, it's very small.
I'm using mobile, so I can zoom in my screen.
Oh, what about now? Is it better now?
Yeah.
Okay. So now, like I was saying, we are trying to check for all possible scenarios. So first of all, name. We want to make sure that name is returning the right thing, which is as at the time where we've not updated it, it should return gospel Isaac. But when we now or update it, it should return something new. You understand? So this is the basic contract. So assuming it was more complex, then we'll start talking about. But basically, we want it to be able to return this these particular values, right? I think you can zoom in. Okay. Yeah. So now let's write test for it. So this should serve as a blueprint for us. This log.js. So let's just write our own test.js. So let's see how they did in this one. So okay, let me make this a bit smaller. So let's see what they did here. They imported these things. I don't think we need time, but we need these load fixtures. So let's just take everything and remove the ones we don't need. So I don't think we need time because this log has something to do with time, but let's remove this time. I think we need load features because for you to be able to use it, you need to get the deployed version, because right now your contract doesn't have a state. So what do I mean by that? Your contract is not running on the blockchain, so it's just running like you can't actually store data. In fact, it's not deployed. Basically, it's not deployed. That's the word. It's not deployed. So we need to deploy to test it. So this load features now has to do with the deployment and getting the data instance. So let's copy something. Let's try and copy this. Let's see. We might just have only one. Okay. Let's just do this. Describe. So based on the test this thing you're using, you might do it differently, but this is for chai. Chai is for you see what they did? No, this is mocha. This is mocha and chai, I think. Well, yeah, this is mocha and chai. Let me go through this. Okay, there's chai here. Okay, mocha is not here, but I think this is what is handling the testing, because chai is just an assertion library, an assertion library rather. So it gives you things like is equal to, is not equal to, is equal, like stuff like that, just for you to be able to compare things, compare values, right? So those are what like chai gives you, but this now adds the whole, because this describe function is not coming from chai, it's coming from this stuff here, which I know normally comes from mocha. Wait, let me go through this one. I want to see where they are doing. I think it's actually in this toolbox. But basically, apart from chai, there's another library that is kind of managing the whole testing. That's what I'm trying to say. The whole testing is not handled just by chai, because chai is for assertions. And that's why here you are importing assert, expect, because this is among it. Expect this is equal to this, is greater than this, is less than this, stuff like that. Will help you draw your comparisons. So yeah, let's just copy this to have, let's call this test, which is the bad name. Call it test. Yeah. So we have this. So inside of this, you can now test for individual functions. So let's see how they did it here. Deploy 1-year log feature. Okay. Okay, let's try to replicate this. So okay, let's read this. So they say we define a feature to reuse the same setup in every test. We use load features to run this setup once, snapshot that state, and reset hard network to that snapshot in every test. So let me explain this, because you would see this coming if you work on bigger applications, and the other tools that will help us do this better. Now, you want to be able to test with the same data, right? So if you've done airdrop before, you must have heard of the word snapshot. So snapshots is just like them taking a picture, not really a picture per se, but they want to know at a particular point in time what were the available data in this system. So this fixture now is more like the snapshot, and is that particular snapshot we use throughout our testing process, so that we don't test here and the values one thing, and we test there and the values another thing. So we are testing with the same data, you understand? And like I said here, it snapshots that state, and it's that state we use in testing throughout. So let me just copy this part here, and I think this is what they used to deploy it, and we just use this, and yeah. So let me remove this. All right, I'll share this code, so you just look at it. So I want to edit their own to fit mine. So out of everything they are showing here now, I don't need all these things, because this 1 year in seconds, 1 GWA, locked amount, all those things I'm not interested in it. Those ones are like are personal to their own. So they say contracts are deployed using the first signer by default. So yeah, do I need this signer? Let me see. Owner, other accounts. Do I need that? Okay, I just need to deploy. So let me just change this to test. Basically, this log here is the name of the contract. So we just change it to test. Right? Because when you compile, you now have that contract here inside this contract. You see this test here now. So this is what to call, and this is how it will now like deploy it and stuff. So let's come here. So this is if you want to pass in a particular amount of ether as at the time of deployment, but we are not doing that here. So we'll just remove that. So the only thing we are passing, as we are not actually passing anything at the time of deployment, let's check. That's just so we are not passing anything. So let's just leave that like that. Then let's leave this and let's call this test. Let's call this test. What is one? Let's return just. So this is the contract and this is the deployed version. So you see here log.deploy, sorry, test.deploy. I'm very sorry if you don't understand JavaScript. I know I'm not doing a good job in explaining what each line is doing, but I don't think this is the time. So bear with me. So wait, let me go back and see. Okay. So yeah, it'd be hard for me to explain JavaScript while explaining this. So maybe if you rewatch this, it might make sense. But I think if you understand programming a bit, this should make sense a bit. Not like it will make a lot of sense, but it will make sense a bit. So this okay, let me return the owner too. Okay, we're not actually using that to do anything actually. Let me just remove this. Let me just say deploy text features. So we have our feature set. So this is what will happen. Instead of us to be deploying it every time, when this is deployed once, we can now use this test to perform audio tests that we need to perform in this test. I don't know if that makes sense. But when I write that, to make more sense. So we have gotten that. So it should set the time on log. Blah 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 blah. So wait, let me remove this. We don't want to hand. Let's try this out. So we want to be able to call functions, right? So let's say let me describe another one. Describe set name, right? Describe set name. Okay. I think this is the only test we'll write. So I want to first and confirm that the name that will return to us is gospel easy. Then I will not set a name that will not test. So let me just do set name. And here we'll now do if you know ES2 syntax, ES6 rather, you know that this is actually a thing. I think I just like it more. But sorry if you don't understand this. I'm very sorry. But it should make sense, I promise. It should make sense. It's not like you need to understand. You might not understand it very well, but it will just be making sense small. So yeah, let's just copy this and edit it to look like what we want. So set name. So it should, let's say, so all these comments makes the test look very look descriptive. So you don't want to go into a test program and everything is looking like rocket science. So when you come here, you should write like descriptive stuff. Okay, no, let me just change this to name. Not just set name. So name. So I'll not say I'll write should return Gospel is a as name. So now we'll load these pictures. Like I said, we'll load these pictures. Then we'll now look for tests because this is what we are having, not lock. Then we'll call the name, and we expect it to be surprising. So what we are doing here is that we're actually saying that we expect test.name to be gospel Isaac because of we said here that as at the time of deployment, the name should be gospel Isaac. So we want to make sure that that's what is really happening. Because you might actually say, okay, this is a simple contract now. I know that all this is about tester. When the program becomes really big, you know that tests are very because this program now is very small. It might be like, okay, we know now, we know it's but when the program becomes really big, it's very hard to keep track of what is and what is not. So let's go back, and I think this is so. Let me just. I think it's npm hard tests. Let me see. I think this is it. Okay, let me compile first and see if I don't get any errors. Nothing to compile. Okay, let me do tests. Let me see if it works. Okay, let me see how many. Would you like to install hard Visual Studio? Okay, wait. Let me delete this thing first. Let me delete this one because it's causing issues. Let me delete it because it's not there again. So to give us, let me try and test again. It said expect to be is not the function. Okay, so let me do expect to be equal. Okay, let me see how it works. So expect to be equal is not expected promise. Expected promise. Okay, sorry. I'll wait. Okay, I'll put await inside here. So I think I'm going to delete what was helping me. Good. So it passed. Wow. So now one of our tests passed. So it passed. So we have await expect test.name to be gospel Isaac, and it's gospel Isaac, right? So wonderful. So now I want to do it should. Wow, that's the but I did not even stress me. So it should set name. Should set name. Right. So basically, sometimes I like to kind of it's not really good, it's not really advisable, but I like to do this repetitive testing where I know that it's redundant, but I just feel like it's good for yeah, I just like doing it. So basically I kind of test that particular function again. So I want to make sure that before I call set name, it's actually gospel Isaac. Then I will now say, okay, since that's that, I'll now do like test dot update name. I think that's what is there. Update name, where is it? Yes, update name. So let's say Rita. So update name to Rita. Then we now want to test again that the new name is Rita. So if this test should pass, so sorry, if this test should pass, then we have actually achieved something big today. So let's save this and pray. Let's see if this works. So boom, it worked. So now we have been able to test that this is gospel Isaac, and we now change the name to Rita, and we now tested that the new name is Rita. So let me change it to another name. Let's not be like it's just one name you're working on my way. So let's say Ogechi and put it here. And like save, try and test again. Our test has passed. So this is how to test in JavaScript. So so does anyone have any questions so far, or should we just go ahead and talk about testing in Solidity?
Please go ahead. There's no time.
Voila. Right.
My question, I'm raising my hand. Quick question. Even
Okay.
though it's showing us that it passed, but it didn't show us the output of what replaced the God's power.
Um, you can try to make your test more. Okay, what if I do? Okay, for tools like Foundry, I know that there's a way to add more. You can make your test give out more output, so it's more descriptive. But let me just do this now. Let me do console.log. Okay, let me say this is name. Let me take this as name. Const name. Also await yes, but name. I want to return the name, right? So it's not be like just me that's doing it. So let me just return the name and it makes more sense. But yeah, I understand you. There's a way to make it more verbose and make the replies more descriptive, but I don't really know how to do that in hard hat. But yeah, so you return Ogechi here, right? So it's not just that it's testing, but it's actually the new name, right? It's actually the new name. So yeah, does this make sense?
Yes, it does.
Okay, so now I would like to show you guys how to write tests in Solidity. But for you to be able to write tests in Solidity, you need to use a tool called Foundry. And Foundry is like hard hat, but it has a lot of features. But one of the most the distinctive feature is that it allows you to write the test, the actual test in Solidity and not in JavaScript. So you see here, we wrote in Solidity, right? And we tested in JavaScript, which you know that this is it's only in blockchain you see this kind of thing. You cannot write your Python code now using JavaScript code to test it, or you cannot write your JavaScript code and use Solidity to test it. Understand? So as a Solidity engineer, you want to be able to do all your things in Solidity. So personally, I'm a big fan of 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 Foundry because I like it when I write tests in Solidity. I don't know, it just feels like it feels normal to me because it's not normal. It's just like in the blockchain is that it has now become a normal thing that when you write your test when you write your code in Solidity, test in hard in JavaScript. But normally you don't. It's not meant to be done that way. You don't write in one language and test in another language. So yeah. So let's see. Okay, let's see if you can do that in 30 minutes. So before I leave hard hat, because this is like I'm done with hard hat right now. So I want to do something on Foundry. So does anyone have any question before I go ahead? Okay, let me check the chat in case. Okay. Um. So yeah, let's create another one called Foundry. Foundry. So I don't have out. So are you telling me that you can confidently work with hard hats now because everybody is saying no question. Is that how you guys are
Ah,
telling me I can comfortably work with
oh,
like apart from the
well,
errors? I understand the errors, but apart from errors, can you telling me that now you can work with hard hats comfortably? Like you understand it.
I don't understand anything about hard hat.
Well,
we are following you, and then we'll go and rewatch and then see how we can do the research on it.
okay.
This thing is not it's not as simple as it is looking, no. But because because you're already used to it. Me that I'm even a complete beginner, is like gibberish to me.
Fine.
You're not the only one. Blockchain is carrying us to where we don't know.
Fine. Don't worry. It will bring you back.
I would have just gone to Web2 quietly.
All right. Okay. So, okay, let me just do a quick walkthrough again of hard hats. Let me do a quick walkthrough of hard hats. Now, if you have used, okay, let me not assume any prerequisite, any that anybody knows anything about JavaScript self. So, first of all, this is a README, nothing much. It's just like for you to be able to like write your description in your project. So this is a README, nothing too much about it, just a README. And do it. It has its own language, but it's not. It does not even have anything to do with JavaScript or anything. It's something on its own. So if you want to explain what you are building, you can come and write it here. Now, package.json is a file that contains all that has been installed in your JavaScript program or in your Node program. Because normally, before Node, JavaScript was run in the browser. Is that even a word? Run, God. So JavaScript, you normally run JavaScript in the browser, but now because you have a compiler or an interpreter like Node.js, you can now run it on your computer itself, not on the browser, on your local machine. That's the word we use. So now this kind of contains everything that you need, right? So before you just come to this place now, let's just say you come to inspect now, and you come to console and you're writing, say you write console or log now, and understand before this kind of things you'll be doing, right? You come here and write hello, blah blah blah. So this is a JavaScript compiler or a JavaScript interpreter. Sorry, it's an interpreter, not a compiler, but basically they're actually the same from a very high level. So, but if you want to be able to build programs that don't run in the browser, you need to have an environment that allows that. So you can't create a backend application that is running on the browser because there are a lot of things that sorry, there are a lot of things that you need. Or for instance, if you want to store private keys, you can't be storing private keys in your browser. You're just shooting yourself on the leg. So that is that. So this file contains all the things you need, right? Then this hard hat stuff, it is specific to hard hat. It's not like all node files, sorry, all node project comes with hard hat. But because of its hard hat, this is like the settings folder. You understand? This contains the settings. On a big project, this modules.export to contain a lot of things. But the only thing that this is containing here is a relative version. But normal, this will contain a lot. Like if you check other project, if I check some other of my projects, it contains a lot of things that we use to configure, right? Then this is the test folder. We just used it. And this is the script folder. So if you want to write like automated scripts, like your deployment script now. So if I want to deploy now to a mainnet now or to a testnet, this is the file that will contain it. And there's a way to run scripts in hard hat. This script too is specific to hard hat. This test is specific to hard hat. And node modules is like your let's say your bean, because it is being ignored. If you see the color, it is grayed out because you won't push it to GitHub because it contains a lot of let's say it's just like noise, basically all the things that you're using. Because for instance now open zeppelin might be dependent on that and that might be dependent on that, and they're just a lot, so they just be inside here, just there. You're not meant to push it. If you push this into GitHub, you spend hours waiting for it to finish, or GitHub might never allow you. So this is the contract folder that contains the contract, right? Then these two are generated after compilation. They are not there normally. So let me try something now. Let me just delete these two now and do compile again. So if I go back, now and do hard compile, you see that it's generated things those two again for me. So it's also grayed out because if you still go, you don't need to push it because it can always generate it. So far you have contracts that work. So artifacts, which is your ABI and stuff like that I talked about. So your ABI will be used when you're interacting with your contract. We'll still talk about that, I think, tomorrow. But we'll talk about Mercury tomorrow. Talk about it as a JS and Web3.js because time is already running out. And Those things are dense topics that we need to do it tomorrow. Yeah. So yeah, basically this is what hard hat's all about. So it might not make sense again, but this is what it's all about. It's not too big, it's not too small. Basically, it's something you can learn. That's the point. I'm not saying it's easy, I'm not saying it's hard, but I'm saying you can learn it, right? So it's not a big deal. There are projects that are more complex than this hard thing, right? So it just helps you, right? So yeah, that's that. So Foundry, I don't know if it helped, but yeah, just this is my attempt of trying to clear some of the confusions you have. So now, there are a couple of steps required to install Foundry, but I've already installed it. So I'll just send you. Let me look for the doc. The same thing, doc. All these things are not, you cannot carry it in your head, but if you know the docs, because just think about the fact that you're working on different things. You can't possibly cram everything that you're working on. So you just they have their docs. I can always go through. So let me send you the docs, and that's what I use, and that's what you use, and just install it and get going as quick as possible. So let me. And another thing is that you don't really need all the tools at the same time. To be honest, you can be very good at hard hat, and you are using it. Any day that they say you should come and use Foundry, you will be able to use it. Do you understand? It's just that if you know one very well, for instance, now Truffle was one of the first tools like this. Truffle and some other ones. I think DAP tools or something like that was one of the first. And immediately people like immediately they release hard hat and Foundry, people start using it. You understand? It's not like there's any special thing. It's just that if you know one very well, you might decide that okay, you don't like Foundry, you're not using hard hat, no problem. You can decide that you want to be using Foundry, but in any case whereby you are meant to use it, you will not find it hard. It's just like okay, what's different? You understand? It's still the same files and stuff like that. So this is a link. If you go here, you can read about Foundry and how to install all these things on your computer. But I'll just start from where I'll start from a place that it will not really take that much time. So if I want to create a project that uses Foundry, I'll do Forge. So if you install Foundry, they'll give you this Forge. It's just like hard hat. So it's just like Forge, hard hat. Instead of you to use hard hat something, you use Forge. So I'll do Forge in it. Um this creates a Foundry project for us, right? So basically, I think it's similar. Let me open hard hat. This one has contracts, okay. This one has source. But basically, if you notice, they are similar, right? This contains the contracts, and this contains a test. Then if you now look at what I was telling you, this test now is in Solidity. You see, it's contract test. The other one was in JavaScript. So this test now is in Solidity. So contracts, and this is some libraries that came. So this is a library that allows us to do the testing thing. So this is a library that allows us to do all the testing. So over 400 and something lines of code. It helps us to do the testing because normally you can't test with Java with Solidity because you need to be on the blockchain. But there's a way they do it using your local machine as your blockchain and stuff like that. So like basically blockchain in the memory and stuff like that. So let me write a quick contract and we'll test. Yeah, let me just write the same contract we wrote before. Let me clear my screen. Whew. Yeah, give me a second. Yeah, so I'll come here. So this is our contract. Let's change this to test and just bring in now our contract. So let's change this to test. Rename to test. Oh, sorry, I made a mistake. So let me come here and wait. Is this is week 5? Yeah, I want to make sure I'm not doing it in the wrong folder. So let me come here and copy that one that we used before. So nothing Nothing to flash. Okay, they already have their own version. Let me not complicate things. Let me just use their own. Let me use their own version. So basically, we have the same contract, right? The same contract. No, nothing special, nothing different. So we have the same contract. Now I want to write test for this same contract, but in Solidity, right? So come here and write. To change this to. Let me just change this to test. And see this convention, you add T. It's not like if we don't add the T to not work, but this thing helps us to like differentiate them. So this one has a T here. If you remove this T, it will still work as a test, but adding it there allows you to be able to differentiate it. I don't know if it actually does anything for Foundry themselves, but I know that for you, even for your eyes, if you see that there's a .t, you know that it's a test file and not a normal file. So it has a .t in it. So let's test. So basically, the way this works is so sorry, let me just give this a test. So the way it works is that we import it here. So let's just import the contract. It's inside of source. It's inside of s. So let's do forge. So the way it works is if you want to run your programs, just do forge, like just like hard compile. We have forge build. Right, so I'll do forge build now. Okay, it has an error, so it's telling us that it's identifier already declared. Oh, see, I use the same name for this and this, so they're telling me that it's the same. So let me change this to. See, you see, I'm very bad with naming. I already named it test, so I'll give it test. Sorry, I'll give it test. Let's just leave it like that, I beg. So now this compiled successfully, right? So now back to what I was saying before. These things are very similar. You see, when I compiled it, okay, I don't know if you noticed, but there are two files that was created recently. But let me delete it again and write and do force build again. So you see what I'm saying. These two files were generated. See, this was generated now cache, and this was generated out. So instead of artifacts, we have out. These things are very similar. If you understand one very well, you can easily transfer the knowledge to another one. It's not rocket science. I promise you, it is not as hard as you think. So yeah, let's see what's inside. The same thing. This ABI and stuff like that. This one, in fact, it's only ABI. They never have all those things on top. ABI, straight up, everything ABI. You understand? So yeah. So let's write our test. Okay. So let's write our test quickly. Give me a second. Yeah. So these are our tests. So what are we testing for? We want to make sure that when you deploy the contract, the name is the name, right? And we want to, when we change the name, we also have the name. So one advantage of Foundry is that you don't need to do this deployment stuff again. See this hard hat thing. This hard hat test, deploy, kini that we did here. This deploy thing that we did here. We don't really need to do it again because of it's just like we are creating a contract instead of another contract. So what we'll do is that we'll just come here and write test. And write test here. So basically, this test now is the contract type. That means this contract that we wrote here, right? So this test now came in, brought in this one that is here. Understand? So just mind you, the fact that you did test.so doesn't mean that you're automatically inheriting this, because this file now can contain multiple contracts. I don't know if I've told you, but this file now can contain another contract like this. Can contain another contract that is called guest or something. So the fact that it has the same name with the folder does not mean that you're importing it. Understand? If I import this thing now and I use it, like if the name was like the fact that the name is test and the folder is test does not mean that I'm importing this one here. You understand? So just take note of that. The file is different from the contract. If there might be multiple contracts inside a file, So the fact that the name is the same does not mean that that's the contract I'm importing. It just means I'm importing the file. Then this contract now can see everything inside this file. That's why it's able to get this test. If it had other ones, to be able to see it too. So that's just for you to take note. So this setup now, this setup was already put in place for us, right? It's already put in place for us. And what it means is that it will run before the test starts, right? So it's the first function that will run, right? So what you will do here is that you will create the contract that you want to be testing. Understand? So what I will do is that I will say test, which is this test that I defined here. This test that I defined here. I'll do test is equals to new dot test. New dot test. What I did here is that this
Please, can you use another word? It's confusing the way you're using only test all through.
oh, I'm sorry. So let's say name. Somebody should give me a name, please. Name for this contract.
What of token? Is it allowed?
That it's kind of abstract, but let me just say namer. Let me call it namer. So this function name, the name function of this name is namer. Sorry, the name of this contract is namer, right? So namer is the function. So let's leave the folder as test. You understand? So let's now call this. Let's call this test folder name test. Let's call it namer test. Oh no, let's call it namer. Then let's call this namer test because of this is the contract of that namer contract that we wrote. I think this is better, right? This is better. So now this thing will no more be test now. The same thing I said is now namer. Let's just call this, give this namer small letters. So yeah, we now have namer, then we have new. So basically you have what we're actually doing here is that what you are doing here is that you are creating a contract. You're creating a new contract and you are setting it to this variable. So now the same way you come here and do uint A. But the only difference is that this uint now you are replacing it with a contract, and that contract in this case is a type. I don't know if I've talked about that before, but you can use a contract as a type. That's why I always talk about going to research by yourself, because to be honest, there are a lot of things that I will not even be able to say because of time and because of I'm a human being and I can't remember everything. But yeah, this is namer and this is now the type. So this is a custom type because this thing did not come with Solidity. We are the one that created this. So just take note of that. So if you have a contract type and you want to create a new contract, you just do new in that contract. But if this was different, say this was uint, a uint value cannot hold the contract now, you understand? So that's why it's like this. So let's change this to test name. Test name. Let's
I have a question.
all right.
This namer with small letter N, can it be something else?
Yes, it's a
Even though the
variable.
contract is okay.
Yeah, it's a variable. It's just like I wanted you to know that it's the same contract. So I just leave it name. It's a variable, it can be anything, but this one must be the name of this contract inside this test, this one. So now I did test name. So I want to look for
Sorry, question, please.
yeah, go ahead.
How about we use an underscore after after that small letter namer to differentiate it from the contract?
Okay, that works. So yeah, this. Yeah. So now I want to now I need a way to be able to assert that this is this, right? So let me come into this folder now that they gave us and look for a let's do assert. So I want to come and look for something that will serve us. Test. Sorry, where will I find this now? Okay, lib. Yes, inside of lib. So source. So you have test. So let me see if I want to compare two strings. asset equal, but for string. Let me see. Okay, don't worry. So basically, if I want to do now this asset equal, okay, I want to say that asset that namer dot name is equal to plus power is in. Now let me run the test and see if it works. So the same thing, instead of hard hat test, you now do forge test. Let's see if this throws an error. It throws an error. It says operator not compatible with type strings, blah blah blah. Okay, you can't use equal to for strings. We actually learn, understand. So take note of that. You can't use equal to for two strings, right? Start they're saying yes. So let's use this instead. Let's use a function that was made specifically for string comparison. So let's do namer, and mind you, this asset equal, this thing I did now is from this folder that I entered, this one. So all these things are pre-written for us. So I want to show you the one that is made for two string comparison. Or it should be somewhere here. So basically, yeah, this should work because it's a string is also a byte 32. It can be a byte 32. So this should work. But yeah, this thing provide, if you notice, they're giving us many functions with the same name. So I told you something about that you can have multiple functions with the same name. So far that it has different arguments. So yeah, let's do this. So I said dot name. Then this takes in two values. Plus power is a. Please works. It should work. So yeah, so test okay, it passed, right? So we've been able to test this. Now there's something that someone asked: how do we make this more verbose? So how I'm going to do is I'll do like I'll add in this thing here. You don't need to cram it, but I've used it before. That what I'm showing you. If I add this thing now, depending on how many V's I add, it increases how verbose it will look. So when I run this now, you see that it has more description. It's telling us how the control is moving. It moves from this control to this control, from this control to this control. You understand? So this kind of adds more description to the whole test process. But yeah, just to show that it's not like just wanted to talk about what you said. So now let's test another function, which is the other one, update name. So test update name. Can you repeat what you just did now? Okay. Like is it the command thing? Okay. So basically I just added, so depending on how many V you add, it is unique to Foundry. If I do test now, right? And I like you can do it for any command. But if you add, the more V's you add, increases how verbose it will be. When I mean verbose, it means more descriptive and stuff like that. So for instance, now if you're testing a code and it's failing, you will need to add this thing so that you understand where it's actually failing. Understand? So basically I added 5. 5 is the highest. If I add 4, add 2, it just decreases how verbose it is. But I want it to be like at its best. I want to see every single thing. So I added 5 V's, like hyphen 5V. So I just did this and it just tested it again, but it gave me like some details. For instance, it's telling me that this is a static call, telling me that I created a new contract here, stuff like that, telling me the gas I used, those details that you would not normally get, right? So yeah, you're welcome. So let's now test for the other function, which is update name. Let's see. Oh, wow, it's already almost 7 o'clock. Well, we're almost done. So test update name. Test update name. So let's do this again. Mind you, don't need to do it. I just like doing these things so that I just know that so that it's not nothing changes, but it's not necessary. So I want to set a new name. So I've already used Rita. I've already used okay. Shall I use another person's name? So name dot update name. So let me use Bakare. Okay. So yeah, I'll use your name. I'll do it this way. So let's now test that the new name is your name. Now let's now test that the new name is your name. So just add that here and we test and it worked. It passed. So sorry, let me remove that plenty vid so you can see it well. So it passed. It passed. You understand? So there's also a way to use like something similar to console or log. So let me look for it inside here. It's called you can use log log string. So but it's an event. So you emit it. If I do log string now, if I come here and do log string now, yes. If I come here and do emit log string, and I want to do the name dot name. But before it shows, I need to add that verbose thing because normally to just show this short stuff here. So okay, let me just show you. If I do test now, you not actually see that it's logging anything, but you just see that the test is passing. You say 2 pass 0 failed is working, right? But if I add the whole plenty vid thing, you will now see that it actually logged back here. Did you see it? So this is an event, it logged it out here. It's just similar to console or log. So at this junction, we don't try for today. Does anyone
Please,
have
can you scroll up the full? I want to screenshot it.
Okay, no problem. This right? But I'll actually push this now. I'll push it to GitHub now, so you can just go through it yourself. So you don't really need to. It's not a must that you have to screenshot it. But yeah, if you want screenshot it, no problem. So does anyone have any question before we go? We've been able to cover some things today. I'm happy about our progress today. So does anyone have any question? Please go ahead and ask. Or if it's not related, okay, go ahead. Go ahead.
The class. I have a question, but it's actually not related to today's topic. I don't know if it's fine.
Yeah,
If
it's
I
fine.
ask
It's
it.
fine. It's fine.
Okay. So it's related to that Ether wallet that we tried to create. So I tried to like upgrade the wallet and add some features that if I want to transfer Ether from my wallet to another wallet, not the smart contract wallet, and I don't want to use either MetaMask or any other. Like I want to transfer it here. I don't know how to do. I tried using transfer from, but anytime I try transferring, it's going to transfer the Ether
From the
back to the
contract.
smart contract instead of to the next instead of to the next to the other account, the other wallet address is going to transfer it to the smart contract.
Okay, so
I don't know if you get.
there's no way to send money from your own account except you're using like normal send, like normal, like for instance now, there's no way for a contract to take money out of your address except you are using like you're adding payable to a function and like passing in value. But if you just say that a function now, sorry, a contract now should just do that, your address, without you having payable in a function, you just take your address and send money out. It's not possible. It's impossible to do it in Solidity. And it's actually good for security reasons.
Okay, so
So
I have to add payable.
yeah, if you want to be able to send money into the contract, you understand? So how it should be done is if you want to send money to somebody, right, you should send it into the contract, then send money to the person and it will now move from the contract. So if you add payable to now, if you call a function send, right, and you add payable to that function, right, So you now send money into the contract. You can now write code that, okay, this exact amount that entered the contract, let it be sent to this person. But the sender now will be the contract, not you. Because the person will see the contract as the sender, not you, but you are the one that actually sends it. But if you just say that the contract should just take your address and send money out, it's impossible.
Oh, okay. Okay, thank
Yeah.
you. Wait, another one. Another one. I came across this that so they want to um like it's an application like a gaming site that they have the site has their own token for like if you want to play. So if I want to play, I can exchange maybe 1,000 naira and to give me like
Okay.
two tokens. So I don't know. They were using PayPal. So I don't know how did they. Is it that they use a smart contract? If I give
All
them,
these systems okay, all these
huh?
systems are not like all these systems, there's no a one size fits all way of doing all these things, right? All these guys are big guys, so they have like highly skilled engineers that can do all these things for them. But basically, they can decide to use contract, they can decide to use, they can even be depend on another provider. Because most of all these things that, for instance, all these Bitcoin and all these wallets, all this any most Nigerian exchanges, anyone you name, they are not really doing all this, doing any smart contracting. They are depending on other services. For instance, now somebody like Bondo now might be depending on a service provider like Binance or BitPay or all these services to offer them to be doing all those address generation. So most times when you see those crypto wallets, I know what comes to mind is okay, wallet and stuff like that. But most times they just depend on that service and they are paying the people. And so far that they are good at what they are doing, there's no problem. So far that your money is not missing and you're sending your money, there's no problem. So just to sum it up, they might build it in any way they like. And most of the times they are dependent on that person, except it's actually a big name like Coinbase now. Hey, Coinbase might be doing their own storage and stuff like that, their own smart contract, stuff like that. But yeah, they might be using smart contract, they might be using anything, or they might even just be dependent on another person that's providing a way to make payment with crypto. You understand? So yeah, does that answer your question?
Yes,
Yeah,
sir.
yeah. All right. So okay, Chi, go ahead.
Okay, I just want to ask what what are the applications of these test contracts you've been writing? What are they used for?
Oh, to test your code.
Oh, that is all.
Yeah, to test your code. Like,
So,
like that's the point. Test your code. Because if you don't test your code, there's no point. You need to be able to test your code.
but I've seen this same test function on Remix. I've seen the same test option on Remix IDE. It's there on Remix.
Okay. I don't know. I don't know. I don't know about that. Well, I don't know. But I just feel like Remix is kind of to be honest, I feel like Remix is just a playground, right? It's not like in a sarcastic way, literally a playground, right? Just a playground for testing out code. For instance, now if you work with a DeFi application, there are a lot of things they'll be doing that you cannot just do on Remix. Like this thing is simple because it's a class. There's a tool called hard deploy. You'll be deploying on audio networking like in a particular folder. You can't do it on Remix, right? You might deploy on Gweli, deploy on Ethereum, deploy on, and it's not like you can't be deploying there, but there's this like you can just be looking at everything you're doing from one particular perspective, and just like there are a lot of things that can really you can do, with all these things. So just know that in as much as Remix is simple to use in a big project, Remix is not an option. If you want to test and you want to just test, like if you want to test concept now, just rush to Remix and go and run it and see if it works. But if I'm writing actual code, like say, in fact, even when I'm writing something like a token now, I'll go and write it on Remix and bring it to my this thing and paste it and make sure that it's working. But at the same time, Remix is just for playground. You just like to be testing ideas and stuff like that. But you cannot really write tests like that. When I finish doing it in Remix, I'll now come back to my Visual Studio and write my tests and stuff like that. So yeah.
okay. Sorry. Another question. all these things we've been doing so far, all the contracts we've been writing and all, are they only applicable to the Ethereum network? Or would they also work for the layer 2 networks, Polygon and Arbitrum and Optimism and the rest?
Okay. So basically, I don't know if you've heard this word EVM chains. So when somebody says EVM chain, just means that any network, that any blockchain network that allows you to use Solidity, because Solidity runs in the EVM. So any network that has an EVM allows Solidity. But if it doesn't have Solidity, so it doesn't have an EVM, it doesn't allow Solidity. So you hear things like EVM compatible chains. Understand? So any chain that they see that EVM compatible, you can write Solidity. So from Polygon, Binance Smart Chain, Avalanche Seed Chain, a lot of chains, right? A lot of chains they allow Solidity, but some of them don't. Like Rust on Polkadot now, you cannot write Solidity. You understand? Polkadot you can't write Solidity. Stacknet you can't write Solidity. But these guys that just came out recently, ZK by Polygon, you can write Solidity. So from the name, you just know that it's a ZK layer 2 chain that allows Solidity. So ZK EVM allows Solidity. So any chain that say that they are EVM compatible, that means they can allow you to write Solidity inside of them.
Okay, thank you.
Yeah, Elizabeth.
Okay, so my question is, now we've seen that we can build and test using Hardart or Foundry. So if
Yeah.
we want to deploy to the blockchain, do they deploy?
Oh,
Or just the way they programmed Remix will compile and deploy to the that we see view on Etherscan. So when we are done with the building and testing on Hardart, if we now want to deploy, what do we use?
okay. So I actually forgot, right? I actually forgot. So tomorrow we'll deploy with Hardhat and Foundry.
Oh, okay. All
Yeah.
right.
Tomorrow we'll deploy harder than Foundry and see it work. But yeah, thank you very much for that. We'll deploy with that tomorrow. And yeah. So I guess that's all right. So yeah, thank you for coming today and have a good night. Tomorrow we'll see.
Thank you.
Yeah, thank
Thank
you. So
you.
yeah, I already deployed all the code that I used today. So you can go and check it out. Yeah, you're welcome.